Okay, thank you for hanging on till the very end of the day. I think I'm all that stands between you and an enjoyable evening somewhere else. So
No.
appreciate it.
No,
There's more stuff? Okay. Anyway, so my name is Tim Bird. I'm chair of the architecture group in something called the Linux Foundation Core Embedded Linux Project. Lately, I've been putting a lot of time and energy into something called the Fuego test framework. And I'm here to talk a little bit about standards. And this is, although I have some standards I'm going to propose, some of the things I'm going to throw out there are going to be kind of soft pitches because I think you guys are already using some of these. But I want to talk about kind of some things that might be good to collaborate on in the future. And first I'm going to talk really quickly, because this is a really short session, only 25 minutes, just about some of the existing open source tests and test frameworks for Linux. There's a lot of things out there, but there's a surprising amount of not sharing going on between the systems, and I'll clarify that more. And so I think it would be a good idea for us to get together on standards. I don't think, I mean, you can, open source, in a lot of places, open source gets rid of the need for standards by sharing implementation because the source code is open. But in this case, I think it's actually would be good for us to collaborate in a few key areas. I'm going to present some areas that I kind of have under investigation and a couple of proposals that I'd like you to consider. And some of those areas are in test dependencies, results formats, and board control hardware, specifically interfaces to commonly used utility programs. And so let me just get right into it. There are lots of test frameworks, but there's still an awful lot that is left as an exercise to the tester. And in fact, my elevator pitch for Fuego is I would like to do for testing what open source has done for software. So right now, a lot of implementation code is shared because of open source, but there's an awful lot of code in the QA department that is not shared. There's code, there's methods, there's procedures, there's formats, there's all kinds of stuff. Even when you get one of these kind of comprehensive test frameworks, there's still a lot of grungy work that you have to do to set up a board lab. And it'd be nice if that was standardized so that hardware could be produced that worked with that standard, and software could be produced that also made testers' lives easier. And some of the things that are left as exercises are what tests to run, how to actually perform the test. That includes how to build it, what parameters to use on the command line, the environment to set up, the test dependencies, what prerequisites does it have before you run the test, and then the results themselves, how to collect the results, visualization, and particularly interpretation and analysis. So who here has ever downloaded and run LTP? Okay, LTP is this big behemoth test program. You run it, and you get like 1,200 successes and 200 failures. And you go, okay, well, what am I supposed to do with that? Do I have to dig into each and every single one of those sub-test cases and figure out, well, does that matter for my use case? And so results analysis and interpretation is just left as an exercise to the reader, and it's one of the most costly parts of the testing exercise. And then how to automate board control, which arguably Lava is king of the hill here in terms of the support it has. So again, because of the shortness of the time, I'm not going to go, I actually have a slide for each of these, but I'm going to kind of brush past these really quick. The first two are kind of large test systems, sets of tests. Well, K-self-test is not that large right now, but it's getting larger for testing the kernel. And then the rest of these are either frameworks or some kind of system. So K-self-test is the unit test framework inside the kernel source tree. The one thing I'll point out on this slide is that K-self-test has just recently converted, or they're decided that they're going to convert all their output into TAP13 format. which is really useful. That means that there'll be a consistent output from the kernel tests that is much easier to parse for results generators. The Linux test project, I already mentioned this one. It's a huge collection of tests for Linux. Covers a lot of territory, syscalls, real-time POSIX. And luckily there is some unification in LTP for the results output. But it's fairly complex to build and deploy. And as I said, it's very difficult to interpret the results. It's very common for there to be lots of failures. Not just skips, where the test itself can determine that some configuration or prerequisite is missing, but actual failures, and you don't know if that is something to be expected for your board or your platform or not. So a tester really has to have a lot of knowledge to use LTP effectively. Fuego, the system I'm working on, it's a framework for collaborating on tests and test infrastructure. Specifically, Fuego is targeted at the tests themselves. So we're trying to build up a whole bunch of tests. You can see we had a 1.1 release in April. I added about 40 new tests. Right now we're at about 120 different tests that we have wrappers for. In 1.2, which is what we've been working on over the summer, we actually have implemented a unified output format. So all of the tests produce a JSON output format, and it is the KernelCI JSON format, which means that we'll hopefully, we haven't tried this yet, but we're in process of making it so that we can send Fuego results to a KernelCI server and be able to use their visualization and their back-end database storage and stuff. We also, in this release, support Lava as a transport and board manager. So this is another thing that we want to do, is see if we can take our suite of tests and then run them basically unmodified on a Lava board farm. Again, not something we've actually done yet, although it's a long story. The AGL project, Automotive Grade Linux project in the Linux Foundation, is actually using Lava for its board farm. And then the other thing we added in 1.2 is a test dependency system. KernelCI, I don't think I need to talk too much about KernelCI. This is a slide that I use with people who are not familiar with it, but I think most people in Linaro know about it. It's this really awesome, doing tons of tests. I actually call it the most successful public distributed build and test system for Linux in the world. If you put enough qualifiers on, you can make it the most. Lava. So Lava automation and validation architecture has very good job control and job scheduling. It's a very comprehensive system. And just in terms of V2, which I don't remember, I don't know how long ago was it when V2 came out? Has it been over a year, or? This is like last fall or sometime, or?
Well,
it's complicated.
It's complicated.
It was February this year where we really had enough support to start driving.
Okay.
Everybody to say, right, you've got to get rid of your V1 stuff.
Okay.
And then by about June, we really had everything nailed down.
Okay. So some of the changes in V2, from my perspective, the job files are now using Jinja 2 templates. Was previously just handwritten JSON. Jobs are running synchronously without polling. ZeroMQ is used for communications. ReactiveBus used to run jobs from messages. And it requires a little bit more explicit board configuration. But I think you guys are familiar with a lot of us, so I'm not going to talk too much about that there. KernelTest is, this is by Gunter Ruck. It's a particular system, kind of predates KernelCI, but builds on every architecture that the kernel supports and boots on many of them on a daily basis, and produces a summary report that you can see online. ZeroDay is really neat set of tests done by a group at Intel. Large set of tests that are run daily on top of Tree, and it has a large test bed. I think they have about 80 tests right now. The thing about ZeroDay that is cool is that it will actually report build test failures for individual patches contributed to the Linux kernel. So it's quite common these days to send a patch to a mailing list and get an automated reply from the ZeroDay system saying you have, this broke such and such a build with this configuration, which is really handy. About 60% of the failures it reports, it does so in under 2 hours, and about 90% within 24 hours. So this gives you really quick turnaround time on the bug reports. Then Avocado, I threw it in the list. It's a virtual machine tester. It's kind of orthogonal to a lot of these other things, but it has a lot of really interesting features. It's got a test server, which a lot of systems have, but the way they implement it is kind of interesting. It's really got a matrix system, and for building, a suite of tests that you compare results from. It actually supports multiple test results output formats, and has a very simple interface to Jenkins, which I think it uses for most of its front end stuff. So what I want to do is separate what I'm going to talk about next into two categories. Things that I'm kind of investigating, and part of the reason that I'm here is to kind of ask you guys questions, and then also proposals that I'd like to propose as potential standards. Not that we're going to make any decisions in a 25-minute session, but things that I think would be really useful, and I think we're close enough that we could actually start to agree on things. So things that I think is really useful. We have something in Fuego called a test plan, which is really simple. It's a JSON file. It's just a list of the tests that we're going to run on a board. And I don't know if Lava has something similar to that or not, but it turns out to be very useful to have kind of a profile, a whole set of things that you're going to apply to a particular use case.
So this is handed over to the QA team, generally within Linaro, so it's Milos who comes up with the test plan.
Okay.
And then that includes something which I'm not sure you're covering here yet, is exactly how to notify the people who care about the test plan. So there's a lot of discussion all the time about exactly what format of content goes into the emails and exactly what wording you want in the emails.
Yeah, so we don't have that yet, but that is a critical thing. Right now we have, Fuego is currently being used by two Linux Foundation projects, the AGL project, the Automotive Grade Linux, and the LTSI project. And so we have test plans for those. So we have a list of tests that apply to AGL and a list of tests that apply to LTSI. And there's overlap, of course, because we run things like LTP on both and some file system benchmark tests on both. But I think this is something where I think it would be good to collaborate on what the requirements are for this type of thing and see if there's some benefit to coming up with an industry standard. I'm not proposing one now. I just think it's an interesting area because everyone has this problem. It's like, everyone solves it because they have their particular use case, and they write, okay, well, this is the set of tests I'm going to run, but they don't share that with someone else who may have a similar use case, right? So it looked like you were going to say something.
Yeah. As far as output formats is concerned, we learned this when we did the V2 stuff. Focusing on the actual format language is the wrong idea. What you want is the schema, because whether it's written in JSON or YAML, as long as you can dump it out into the format that it actually wants, it's actually the structure that needs to be standardized, not the language it's expressed in.
Okay, that's good. I'm going to have to, I was going to write down, but I'm so limited on time, I'll have to remember this stuff and write it down. Okay, so I will get to output format in a bit. So test dependencies. Another problem that testers have is that and this came up, this is over the summer, there was a lot of discussion about this particular issue on the K-self-test, which is how do you know what tests to run or if you have the right prerequisites for a test. In the case of K-self-test, it's the dependency is a particular kernel config item. Right, and so everybody needs to, you need to have that or the test, it's like dead in the water. And you don't know, and as a poor old tester, you don't know if the failure came because you actually have a problem on your system, something broke, or just because you didn't have the right config. So there's kind of two reasons to need this, to avoid wasting time with tests that won't work. And then also just as a document, to document what the prerequisites are. There's lots of different prerequisites or dependencies. Some of them are like the amount of memory needed for a test, in particular the kernel configuration, how much storage, what type of storage, subsystems and libraries might be required for a test. And then as we get into more hardware tests, you need to know that you actually have that hardware. Otherwise it's just pointless to run a test. And so there is some existing support for test dependencies. I will admit to in Fuego shamelessly copying the stuff from ZeroDay. So ZeroDay has a thing neat, and they just declare some variables in one of their YAML files that says need kernel headers, whether that's true or false. I presume that's for part of their build phase. And then need a kconfig, and they can have a list of kconfigs that are needed. Need memory, need CPU. We have 3 in Fuego. I don't know if there are specific other ones, but I think it would be good to come up to have the same types of mechanisms, or at least the same types of vocabulary for talking about this stuff. It doesn't have to be needed by identical, but if you can, it'd be really nice if someone could say, oh yeah, abort 07 in, or I notify 06. That's the one I had problems with in LTP just recently. I notify 06 requires this thing to be in the kernel. It's like, well, okay, well, that'd be nice to know instead of just getting a failure and then having to dig into it myself. A couple of interesting notes. So both ZeroDay and Fuego, because Fuego copied ZeroDay, use a declarative syntax rather than imperative. So we're not actually executing some code to do that. I think that's really important because that makes it suitable for static analysis. So you can actually determine ahead of time, before you even run the test, you could run an analyzer and say, well, this board has this configuration, and this test is not even going to run. Yeah. Okay? And you don't even have to install the test, theoretically, to make that determination. So in my wildest dreams, I envision an online test store, kind of like an app store, where a user can go out and say, oh, this one's highly rated for measuring file system performance. I want to get that one. And then that can be matched up with, but it's an ext4, test. It's not a, Riser FS test. And other things like tests for specific hardware. Like if I don't have a CAN bus, I don't even see in my download list the CAN bus tests. Fuego also has some imperative checks that are kind of leftover legacy, but we'd like to convert those. Right now, we're testing for things that are on-target specific binaries or programs or libraries. The same thing with the SDK, because we build tests from scratch. So we got to make sure that the SDK has the appropriate libraries. But those could also be made into declarative syntax. Okay, so that was the investigative stuff. And actually, I lied. I'm going to come back a little bit to investigative. I got to watch my time here. Oh, man. Okay. My proposal. My preferred test output format is TAP 13. That is I'll show you TAP 13 in a second. I want to talk a little bit about TGWIDs. That's my own term. What Kernel CI, what it looks like, and then what we've got in Fuego. So I think this is actually a key idea, and that there be a string that uniquely identifies a particular test case or benchmark measure. For instance, ltp.syscall.abort01.1. Okay, that refers to a very specific test case inside the LTP system. And it's useful for data information interchange. It's kind of similar to a URL, Uniform Resource Locator, in web terminology. It's used to refer unambiguously to a particular test case. And there are some issues with this because even inside LTP there's aliasing issues. The same test can be run through multiple plans.
There's issues with that with a lot of the Android stuff as well because they do repetition.
Right, oh, okay, yeah. Oh, okay, yeah.
And they do repetition, they do parameterized repetition as well, so they actually change the environment and the config at the time.
Okay. Well,
without changing.
I have some ideas how to, well, anyway, okay. Yeah. So the benefits though, if we can pull it off, which maybe we can't, I don't know. But it's really good for discussing specific test cases. It's good for dating mining across platforms. So you can, if I'm having trouble with iNotify6 inside the test framework, Fuego test framework, I can go look at Linaro to Kernel CI results and see, well, is this something that's given a problem with other platforms? I don't have it. So the metadata can be independent of the framework. We can have things like description and analysis and things like that. And I just think that the first step to sharing information between systems is trying to come up with some kind of consistent reference mechanism. So I think that's important. Now, the output format, this is different than, I make a distinction between the output format and the results format. The output format is what actually comes out from the test. there's no way we're going to go back and convert the output of hundreds of thousands of tests. So we're going to have to deal with the fact that currently lots of output exists. It's really ad hoc. Testers have written any old thing they want. Luckily, a lot of them are line-oriented, so it is possible to parse a lot of things. K-self-test is adopting TAP, the Test Anything protocol, and I would just throw that out there as a suggestion. If you're writing a new test today, particularly a smallish type test, just use TAP. I know it's not the prettiest one in the world, but if we all support it as input to our test frameworks, then it's automatic, right? Then we don't have to do anything else. TAP, here's an example TAP. It's like the simplest output format you've ever seen. It's quirky, but it gets the job done, especially for small tests. So if you're a test author, I'd recommend you look at this. Now for results format, the big one that seems to be popular in a lot of places is, well, JUnit and XUnit, which are really the same thing. They're XML formats. And that in itself, I'm not a big XML fan, but it does get the job done. Oddly, XUnit is missing the pass results for individual test cases. It has aggregate results and it has errors, but it doesn't actually have, like, if you have a test case that passes, it doesn't list it individually. So I actually don't think it's a great one. I like the KernelCI one. And it happens to be in JSON, and so I actually suggest that as an industry, we adopt that going forward. So there you go. That's my proposal. In terms of results parsing, this is not so much something we have to standardize because a lot of this stuff is fairly simple, but you do need an abstraction converting all these non-standard test outputs to a standard results format. We have in Fuego 80 parsers already for different formats, including ones from TAP and and LTP and a lot of other tests. We can convert those into what we call a run.json, but it's the KernelCI format. And then I don't know if do you guys have in Lava some kind of generic parser mechanism for?
No, it's left entirely to the test writer. All we tell the test writer is they need to call Lava test case.
Okay.
And then that handles all the creation of the results from there. But they can call that however they want to, whatever.
Okay. So if they're adapting an existing test like XFS tests, they have to do the conversion themselves. Yeah. Okay. Okay. Well, I'm already over time. I got it. So and this is a really big area. Board and test environment control, power control, file transfer, remote execution. It'd be really nice if we could standardize on this. So really what you have is you have tools that provide an abstraction for these things like turn the power on and off, communicate with the board, execute command on the board, and there's kind of a fixed set. There's actually not that many verbs. There's really only about, in Fuego, we really have got it down to about 4 main ones that we use. But the problem is there's always kind of these little exceptions that you have to deal with. But if we could get kind of some standardization on power control and command execution and file transfer, that covers a huge amount of territory in terms of this. So Lava board control operations, these are the top 4. That are really critical: power off command, power on command, connection command, and hard reset. There's soft reset, and there's a bunch of other ones, but these are kind of the real key ones. If you have these, you can do an amazing amount. TTC is something we used at Sony that also has a set of verbs, very similar. The important ones here that correspond to the ones in Lava are copy to, copy from, run, and reboot. Reboot line? No, reboot did not. Oh yeah, there it is. And it's a thin wrapper for abstracting board-specific operations. So Fuego has a model of much more direct interaction. That during the test, we communicate with the board, deploy stuff, and retrieve stuff. I'm not sure how that corresponds to how Lava runs. Lava seems to do much more like a set up a big thing and go.
Yep.
So
we give the test writer enough rope to hang themselves, and they often do.
So power control, I was looking at the Lava code from the latest release. Almost all of them are either PDU client or SMP PDU control with a couple of outliers in there. TTC uses something called power control and does echo. Turns out that TTC is used a lot with a particular debug board that allows you to do commands over serial and web relay. It'd be nice if we could standardize this interface so that if someone comes up with a new board that can manage other boards, they just plug into the interface. And maybe that's PDU client. It could be PDU client. But that's something, I think it's worth having that discussion.
Okay.
And see if we could standardize that.
My colleagues in Samsung, you remember the SD Max?
Oh yeah, yeah.
They're working on the new version. It's ready. I have seen the prototype, the MUX5. You may try to Google it. And it uses the Ethernet connection. So they try to abstract the board on the steering board itself. So there is the universal interface.
Oh, they're putting a power control on the
yes
device under test.
The power control. There is the universal connection via the Ethernet, and then everything which is board specific sits on the steering board itself.
Okay.
So you don't need to care with this from the.
Actually, we're seeing more and more of that because a lot of stuff. I'm seeing a lot of board. I have 2 boards in my lab now where the serial port, the serial console, they have a serial to USB on the board.
Yeah.
Right.
Yeah.
So it'd be nice if we could standardize that so it's not all random, right? I'd be very interested to see exactly like what interface they chose to do that with. And are you guys plugging that in underneath PDU client or?
Well, I don't know how they do this. I'm out of that project. I know the construction of the board itself because I helped them. And they are able to connect via serial. There is the serial interface for mobile phones. There is the Ethernet to the board, which is tested, so SSH, etc. The serial console with JTAG and other stuff.
Okay.
The standard one.
Okay.
Nothing big.
Anyway, I think that, so at Sony we end up using a lot of we have some separate boards, right, that manage connections with the device under test, and so we use a USB serial interface, and we're just doing character commands to a serial port on Linux to do things like power control and flip USB buses on and off and stuff like that.
Okay, in terms of commands, all commands are sent via Ethernet. There is the NanoPi board, which is connected to the network, and everything which is board specific, I mean the board under the test specific, sits on that NanoPi and it controls via the specific interface. It depends what your board has.
We should definitely talk more after. Are you going to ELC or?
Yes.
Okay. Well, if we don't get more time here, I'm sorry. I'm like overtime, and I apologize for that. File transfer. There's a bunch of different mechanisms being used. I don't know if it's that critical. You guys are using SeroDay.
That's hardware specific. We don't use SeroDay for file transfer. We never transfer files over serial.
That's just the console management.
Oh, that's okay.
We never transfer files over serial.
So what do you require networking or?
Depends entirely on the device, but a lot of devices, the simplest ones, tend to use TFTP. And if they can do that, then everything becomes a lot easier. A lot of other boards use fast boot flash, not ADB. ADB is for transferring files during the test operation, but to actually deploy files, transfer files to the board to construct the test in the first place and get the board running, that needs to be fastboot or TFTP or Pixie or
Okay, so from our point of view, there are 2 options. We use the SD card, the multiplexer. It's also in the MUX5. So we are disconnecting the SD card, flash it, or put some file and to reconnect it to the device.
Yeah. We've had so many bad failures with a variety. We've tested at least I think now a dozen different implementations of SD MUX. I'll point you what the requirements have actually got.
Oh, okay, but it's working. It's working for over 2 years, and there is no problems. And another approach for boards which are booting from pen drives, not from SD cards, we can emulate the master NanoPi itself and connect it directly to the board.
Okay, so like I said, I'm over time, so I'm not giving this stuff as much airtime as it deserves, but there's also just direct command execution. I don't know how much of the stuff, I don't know how much commands you execute directly on target, like during tests, or if it's all kind of, once you set up the test and go.
During the test, all we do is let the test writer script run.
Right, okay. But there seems to be some unstandardized things, and particularly button and bus control. So there's a lot of tests, particularly hardware tests, where you want to be able to simulate pressing of buttons, or you want to be able to turn buses on and off to simulate plug and unplug devices, USB switching. There's complex boot modes, particularly like phones have a lot of weird things. Just to get into reset mode, you have to do odd behaviors.
Those kinds of things just get soldered away.
What?
They get soldered away.
Yeah, well, that's the thing. Is they get solved. Everyone solves it in a custom way. It'd be nice if we could at least come up with some guidelines saying, hey, if you solve it this way, then then the test frameworks know how to communicate with that. And then I'll just sorry for going over. But next steps. If we wanted to do some standards, how would we do it? I would like to have the groups get together. There's a couple of ways. Since it's open source, I don't know if you see bullet point number 4 there. One way is just to go into the other projects and contribute support for something, right? If you want them to support the Kernel CI test format, you can go into Avocado and you can add it and say, hey, take these patches. But it'd be nice to make sure that we're handling everybody's requirements. So I don't know, is it worth planning an event or a summit? I know Plumbers just had a kernel testing track, but that's not exact. I don't think it's not the right venue. I think there needs to be a group of like us framework guys who get together and say, what would be valuable to our frameworks if we collaborated on it?
Should we at least start a mailing list?
Well, we should be documenting it, yes. Well, and quite frankly, Kernel CI, one of the real great things about Kernel CI is they had their schema online. So we were able to look at it, and it was invaluable when we were, not reverse engineering, but when we were implementing in our tool, to have that documented was really handy. Anyway, I don't know if we're going to decide anything right now, but that's kind of the direction I'd like us to head, and maybe we can talk more.
That's fine, Tristan, during the week.
Yeah, okay. Thanks.